All right, thank you everyone for joining us today for the Alerts and Brokers session. My name is Eric Bellum. I am co-chairing this along with Brian Miller, who is unfortunately under the weather. He is on Zoom with us today. He did all of the heavy lifting getting this session together, which is a nice full group of talks from brokers and related services, which you can see here. So we will work our way through that together. Just a reminder, stay muted if you are online. Use a mic when you ask questions. There is a Slack space, and we will use the usual Zoom tools. We have a code of conduct. If you're not feeling well, please follow Brian's example and stay in your room. And hopefully, that will be not a widespread issue. So let's go ahead and begin. I am actually the first speaker. So I have given myself the full 90 minutes. No, I'm just kidding. I have 7 + 3 to give a quick status report on alert production from the project side. So let me pull that up. All right. All right, so my name is Eric Bellum. I'm the science lead for alert production for Rubin, and I wanted to give you just a quick update on how we are doing on the project side as we get ready for alert production. I don't think it is news to anyone here. AP is one of the 2 main ways you get Rubin data, the other being the annual data releases, which are a systematic reprocessing. Alert production is the near real-time analysis of the data as it comes off the telescope, where we rapidly image difference the images and find things that are changing and send them out to community alert brokers, thereby enabling the broader scientific community to make discoveries and conduct follow-up very quickly. It's based on the technique of image subtraction. Again, this is familiar to most of us. You take the new image, you subtract it against a co-added stack template image, and then you look for objects that are varying above a significance threshold in the difference image and find the things that are changing. We're using as a baseline the decorrelated Allard and Lupton algorithm for those who are aficionados of difference imaging. If you're curious about the schemas and catalogs, the data products definition document, or DPDD, is the reference. That has been something the project has been carrying along for quite some time. And so if you're looking for what's implemented in software right now, I want to point you to the schema browser, ls.st/schema, which has for alert production as well as all of our data releases, the sort of as-built tables, which sometimes differ slightly in sort of capitalization and naming and so on from what was in the DPDD. So the idea of alert production is to rapidly send out all the information that we have about a new source to enable rapid decision-making and follow-up. So in particular, that is the database records we have about the difference image source, or DIA source, the associated object, or if it's a solar system object, the SS object. There are 12 months of history, upper limits, time series features, cross matches to data releases, as well as postage stamps, all included in the alert packet. It's worth saying that some of these things aren't available yet. In particular, we don't really have data releases that we can match to at any scale, so those won't be in our early alerts. And there are a few other features that we're still working on as we go. Those alerts then get sent to 7 community brokers that were selected in a process a few years ago. They are all around the world: Alerce, Ample, Antares, Bobomol, Fink, Lacer, and Pitt Google. There are also 2 additional brokers that operate downstream of the full-stream brokers. And those are Snaps here in Arizona and the POA variables broker. So we will hear from several of these brokers later in this session, but all of them are active now and preparing for alerts. We have done some exercises with these brokers to try to get ready for the full Rubin stream. So we did a couple of exercises as part of Rubin's operations rehearsals, where we were processing simulated data, simulated images, and sending them with the production sort of Kafka services to the brokers. I think we learned a number of things from those exercises, among them that simulated images are not as informative as real data, but they were a way to sort of test that the connections were working and that we understood the interfaces. Where in particular, the alerts are designed to be world public, and so our aim is to always send public data to the brokers. If you're curious about image differencing performance, I point you towards Data Preview 1, which is the release just a few weeks ago of the ComCam data. That was not alert production, but we did run difference imaging and many of the sort of same pipeline components. These will be discussed more in Wednesday's updates from Science Pipeline session. I would say the broad takeaways from my perspective are that most of the difference images are pretty clean. The artifacts that we tend to have are dominated by sort of bright star artifacts, and so there some work for us to do to clean those up and work more on identifying those. But the completeness, as shown in the histogram on the right, is quite good. This is injections of point sources, and we have a machine learned reliability or real bogus scoring system that is showing good performance on transients and solar system objects. And we know that we need to improve on variable stars because they weren't included in the training set. So we're making plans on that going forward. Again, there'll be an update in the Science Pipelines session on Wednesday. We're getting ready to send first alerts relatively soon. We have a document that sort of laid out all the things that we think we wanted to have ready in order to start alerts, and now we're figuring out if they're all actually required. In particular, the biggest blocker at the moment is we have to get approval from the agencies to be able to start sending alerts. We're still waiting for that and expect it relatively soon. We're not requiring ourselves to have every checkbox finished in terms of every column filled and every data product available. We're eager to enable early science. And of course, the brokers also need to be prepared. And so there'll be a period of commissioning and integration that they'll need as well. So we'll talk a lot more about timeline and sort of the near-term blockers here tomorrow in the early science session. So just some of the things that we're working on in AP is, there's always more that we can do to make image differencing cleaner and better. And in particular, in the early survey, the templates are going to be, relatively shallow, relatively sparse. We have database and speed and robustness sort of activities that we're working on. We're quite close to having all of the solar system object, the known objects fully integrated into the alert pipeline. I already mentioned improving the ML real bogus system. We just recently implemented a feature that allows us to identify glints from rotating space junk and satellites as they sort of track across the focal plane. So we'll be rejecting those. And then of course, there's a requirements verification for the construction project that we're continuing to work on. So generally, I would say this graphic is a little bit old, but we're right on schedule. We're kind of here in the end of system optimization, start of science validation surveys, looking at sort of high latency alerts, community broker integration, and then working into an increasingly live, increasingly voluminous alert stream as we start the main survey. So I will stop there and take any questions. Thank you very much.
Hi, Eric. That was great.
Thanks.
One thing I'm still murky on, there's this 80-hour rule and maybe a 12-hour rule. Can you maybe break down when certain data products will be available
Yeah.
after an alert, say?
Yeah, so the alerts go out as soon as we can. You know, the target is 60 seconds, but right away, and they have image stamps in them. After 12 hours, we're able to release the catalogs, and 80 hours, the pixel data itself becomes available. That's all in steady state, as we'll talk about some in early science tomorrow, and I think was at the SAC meeting today. The services for the prompt catalogs and the image services are not ready as of today. So.
And just to help me clarify, what is in the 12-hour catalog that is not in the alert?
Maybe some force photometry, but basically nothing. It's just a relational view of the same data that's in the alert. It's just a different way to query the same information.
And sorry, last one, I'm still trying to get this
No,
all
yeah.
straight. The 80-hour image,
Yep.
Can we do that? Can we request that image anywhere in the sky, or does it have to be associated with an alert?
It can be any. So the alerts are cut out from large images.
Yeah.
After 80 hours, you can download the subject to rate limits and all of that, but like you can download the whole image. So there's no, you know.
Okay, that's good. Thank you.
Yes, you can access it through the science platform.
Well, if I want force photometry limits, I really need, and you won't give them to me, like I can't, I had a random position in the sky, ask for force photometry. I do need the image, right?
Yes, that
Sorry,
we,
Bob.
we will compute force photometry ourselves for our own sources, but you're right, for an arbitrary location, you would need the image to do your own force photometry.
Along the same lines, with what accuracy do you report in the 60-second alert the position, the astrometry?
Oh, that's a great question. I don't know off the top of my head what our astrometric accuracy is.
Well, you must know, because you succeed in doing the difference imaging just exquisitely. So you must have aligned them, and you must know the position of one of the two.
There's a plot in the let me get back to you after I get off the stage here. There's a nice plot in the DP1 paper that shows for injections our astrometric recovery of positions, and it was indeed good, but I don't remember the number.
Thank you.
All right, I'm going to let Bob go, of course, and then we'll go to the next speaker.
No, can you just give us a little expectation when we start with the first alerts, that latency? Are we talking a week, a day? What's the latency?
Our system, I think it's minutes. You know, it's minutes or nothing, right? Because the system is designed to run in real time. We do expect to be able to reprocess data if we have to, but that's something that is, you know, kind of an intermediate term goal. So yeah, it's a, you know, several minutes, or we missed it probably in the early going.
Thank you.
All right, let's go to our next speaker, who is Melissa.
All right. Okay. Hi, everybody. My name is Melissa Graham. I'm the lead community scientist for Rubin Observatory, which means I lead the community scientist team, and we call them the CST. Our charge is to facilitate scientists and students from across the global Rubin community to do science with the Rubin data products, services, and tools. This includes resources like documentation, tutorials, and virtual seminars. In particular, to facilitate scientists to use the alert stream, CST aims to develop and implement and then validate about 20 community filters with the Antares broker, starting with about 5 this year as alerts get started. These community filters, we want them to be designed to prevent redundancy among user-defined filters. So if there's common things that everybody is going to need a filter for, we should just take care of that for you. We want them to together as a set serve a fairly broad range of time domain science interests, but the whole point of a filter is to meet one well-defined science goal. So we're trying to balance those two goals there in defining these filters. These filters, they also need to significantly down select the number of alerts per visit, just like any filter, in order to be usable. And we want them, they have to be subject to technical constraints. They have to run at Antares, and we want to maintain them throughout Rubin operations in a stable way so that you can do long-term science investigations with these filters. So we started the roadmap for building these community filters this year. You can find it in RTN 090. Oh, it says something else. Want me to stop and reshare? Oh, we're sharing something else. David.
Ah, okay, so it's paused because of a permissions thing. Easiest way around that, we're just gonna share the entire screen. And then if we do slideshow. Looks good, looks good. Is there anybody online that can just double check that they can see the slides?
Good now.
Thank you.
Thank you. All right. Give our online folks just a second to look at the slide that I just spoke to. All the slides are linked from the session page, so you can go grab them for yourself. Right, we were here. Rubin TechNote 90 as our roadmap for community filters. This spring, we started by collecting community input on what kind of filters people would find useful. Over the summer and probably like into the fall, we're going to be defining those first 5 filters and implementing them. We anticipate running some virtual seminars later on once they're up to encourage use and adoption. We're going to collect feedback and then refine and create new filters as we go, as we build up to those that goal of having 20 community filters. So the first call for input went out on community forum. The deadline was Friday, May 30th. And the request was just for people to contribute a short statement that either proposed a specific filter, like in words or with code, or just to describe a science case that that filter should meet. In total, we got 17 responses, 12 from related to transients and variables, 3 for solar system, and then 2 were related to like strong lensing, dark energy, and cosmology. So good variety, good number to work with. After discussions with Antares for sort of what we thought we wanted to do and what is possible with Antares, we kind of have a rough list of our targeted first 5 community filters. So doing something with intranight confirmed but hostless transients, young transients in nearby galaxies, pretty obvious one. Transients that have rebrightening in order to probe circumstellar interaction at late times. We want to look at doing something, have some sort of machine learning photometric classification community filter, and at least one solar system related community filter if possible, something to do with the photometry of the moving object, something that brightens, for example. So this is what we're thinking to start with. This might evolve as we actually get to the point of trying to implement these in Antares and as we learn more about how Antares works. This list is not posted anywhere yet. It's coming soon. I'll put it up on the community forum. And when I do, it'll come with details about why these ones were selected, what other suggestions came in, what other sort of implementations we envision for things that we didn't select, that kind of thing. So you'll get some more information about this. And I wanted to bring to light that this call sort of revealed, I call it an interesting misunderstanding, but no one was really wrong. It's just our original call for input. We requested descriptions of like general scientific analyses that people thought they might need to do. We really wanted to, the whole kind of point of community filters was to avoid people having to learn about broker internal functionality and avoid them having to go in and design and write their own filters and to do that work. But quite a few of the responses that we got indicated that people thought we were asking for very specific, fully designed proposals for filters that would definitely work and be awesome, or that we were looking for suggestions from people who like already really knew how Antares worked and that kind of thing, or they thought this was a call was a way to get help with Antares. So it's kind of, there's a bit of a mismatch between what we thought we were asking for and what we heard, but it's extremely informative. So it's kind of like if I ask you what kind of sandwich you want and you said a Diet Pepsi, and I'd be like, oh, you're thirsty, not hungry. Let's get you a drink instead. So we're gonna still work towards building community filters that serve people who don't know how alert brokers work and just kind of know what kind of science they want to do. But on the way now, we're kind of thinking to expand this roadmap, and we really want to incorporate the people who did provide responses to this form, maybe have some co-working filter development sessions, maybe bring in some of the people who responded who clearly came in sort of with very specific ideas, but they need help implementing it. So yeah, we're thinking that we'll expand this whole effort a bit so that we can all learn together, and we'll still have the community filters, but this should help the community also to build their own filters that they need. So I thought that was pretty interesting. And that's what we're doing. That's what you'll hear more about over the year as alerts get started. I can take, I think, a few questions on that.
Why was this phrased as Antares filters and not just broadly the CST team focusing on broker filters?
Yeah, we are specifically partnering with Antares to build the community filters on purpose.
Please, Bob.
There was a construction project requirement to deliver a basic filtering capability, and the project realized it would be straightforward to satisfy that requirement by working directly with Antares. That's all. Okay, sorry about that.
I think the call might have said something to that effect, but we didn't think to make that super clear. Sorry. Yeah.
My name is Schechter. I submitted one of those misunderstanding proposals.
Oh, wonderful. Okay.
And I don't understand to this instant whether the community team is the right team within which to help develop some code, or one of the brokers is. So should I be shopping for a broker, perhaps other than Antares, or should I talk more to you?
I think both. I think definitely we advise people to look at what all of the brokers are offering. And we recently sort of redesigned our broker webpage at rubinobservatory.org to try and encourage people to look around. So definitely, yes, shop it around, and also definitely talk to us as well. So kind of both things.
All right, last question.
So these community filters, these are not the only filters that would run on Antares, is that right? I, as a user of Antares, will be able to write my own filter completely independently. So this is more just for folks who want to avoid writing their own filters.
Exactly. Yeah.
All right.
Yep.
All right, let's thank Melissa again. All right, next we have Chris Hernandez on the Pit Google. Do folks online see just the single slides? Or are they getting the? Let's just do this.
It's good.
Okay.
All right, thank you. So I'm looking out into the crowd and I'm seeing a couple of familiar faces, and I'm also seeing a lot of new faces. So in case we haven't had the opportunity to meet and interact yet, I wanted to start off by saying hello. My name is Chris Hernandez. I'm a graduate student at the University of Pittsburgh, and I'm currently the lead developer for the Pit Google Alert Broker. And so throughout the session so far, we heard in Eric and Melissa's talks, we've heard them pose and provide answers to a couple of questions, namely, what are alerts? What information do alerts contain? And how can we use brokers to filter alert streams to identify valuable information that is useful for my or our particular science case? On a similar train of thought, my goal for today is to pose and provide answers to questions centered on the services that the Pit Google Alert Broker provides. And so let's go ahead and get started. So some of the common questions that I get whenever I introduce the Pit Google Alert Broker are, why are you called Pit Google? And also, why don't you have a logo? And so the answer to the first question is actually relatively straightforward. We are the Pit Google Alert Broker because we've embraced cloud services as a solution to the challenges our field currently faces in data processing, transport, and storage. So what this slide shows here are some of the common cloud services that we use to distribute broker data products. These are namely PubSub, Cloud Storage Buckets, and BigQuery tables. What's also shown in this slide, I think, is a reflection of the significant amount of effort that's been put to include additional surveys and collaborations to really allow the ability to conduct multi-messenger astronomy analysis. And so the Pit Google Alert Broker started off by ingesting, processing, and serving broker data products from ZTF. But over the past year, I've worked very diligently alongside our team members to include broker data products from the LIGO Virgo Cogra collaboration, Swift, and of course, the Legacy Survey of Space and Time. And I think everyone here in this room can agree that there's the general consensus is that the primary responsibility for brokers is to enable access to alert streams, primarily the LSST alert stream, but to not only provide access, but to add value to that alert stream. So I thought it would be very fitting to use this time to highlight one of the cloud services that we use, namely PubSub Topics. And the main message that I want to convey to you is that these topics are our method of delivering not only the LSST alert stream to the entire world, but also the value-added information as well. So here we're outlining some of the topics that we serve with the Pit Google Alert Broker. I'd like to highlight as well some of the metadata that is included with the data in the messages that we publish to this topic. Some which may be of relative importance. And I guess it depends here on the science case that you're particularly interested in. One of the features that I like to highlight here is the fact that HealPix orders 9, 19, and 29 are included in every single message that we publish to a topic, well, along with the others that you see here. But if, for example, you're interested in identifying alerts that are associated with a particular region of the sky, it's actually very straightforward to do so with the Pit Google Alert Broker. So any user, anyone with a Gmail account, not a Gmail account, an email account, can create an account to the Google Cloud platform and create a subscription to one of our topics. Not only can you create a subscription, but you can also create a subscription that acknowledges messages with the metadata that you see here. So for example, if you're interested in identifying objects that whose N previous detections is not 1 or is not 2, so basically anything higher than 2 detections, you can specify that and you'll only receive those messages. I'll add on to the list of PubSub topics that we have. These are examples of some of the value-added streams that the Pitt Google Alert Broker has. And many of these streams have been motivated by conversations that I've had with individuals from different science collaborations. So I guess in particular for time domain science, if you're interested in the results of photometric classifiers, that has led to the creation of our modules to identify likely type 1a supernova candidates, in addition to maybe some value-added streams like identifying potential variable objects and also classifying those objects. So I don't have enough time to show you everything that I would like to share with you. So I've added these QR codes to help out with that process. I have been working on the Pitt Google client, which is a Python library that we maintain to access, this can be used to access astronomy data that we serve, as well as the GitHub repo Pitt Google user demos that outlines some concrete examples of how one could even containerize their own code, deploy that container to the cloud and run their own analysis using one of the topics as a trigger. So some quick examples that I have using the Pitt Google client. It is extremely straightforward to go ahead and define a topic, define a subscription, and to go ahead and create that subscription. It's also very straightforward to go ahead and pull some alerts from that subscription and work directly with that data. Some of the examples I have, you can manipulate that Python object. Here, that object is called alert. You can see the attributes associated with that alert. And well, you can do a lot of fun things with this. If you're interested in hearing a little bit more about that, feel free to reach out to me. But I guess the message that I want to leave with you today is that communication is essential to the growth of our fields. As I mentioned before, many of the modules that have been deployed through the Pitt Google Alert Broker has been a result of conversations I've had with scientists. So if you're interested in exploring specific science cases, please reach out to me. I am extremely happy to work with you and to get some science. And so, of course, again, a quick summary. The most common cloud services that we use are PubSub, Cloud Storage Buckets, and BigQuery tables. And we also have a Python library that you can use to interact with the broker data products we serve. Thank you.
Questions for Chris?
Tim Lister, Las Cumbres Observatory. What support do you have in Pitt Google for moving objects?
Could you elaborate on that a little bit more?
Solar system objects, asteroids, comets,
Right.
Trans-Neptunian objects.
So this
Things
is
like stay in 1 RA in deck.
This is a subject that I am actually really interested in exploring further. Most of the support that has been implemented is for the identification of variable objects and using photometric classifiers for transient classification. And so truthfully, not a lot of work has been implemented for solar system objects. And I'm really hoping to have more conversations to develop that infrastructure.
Can I include the email addresses of 10 or 100 of my best friends?
If
Or
you want.
must I do that, reroute it once you send it to me?
Um,
I'm not the only one who's interested in my query, but will you send out 10 or 100, or do I have to reroute it and send it myself, resend it myself?
are you asking in the context of creating an account to access our broker data products?
Yes.
Yes. If you give me a list, I'd be happy to help out with that.
So I can give you 100 names to send these alerts to, the ones that we selected.
No. So every individual who would like to access our
Okay, it's
data
for
products.
individuals.
Yes.
Fine. And then I have to take it and send it to my 100 best friends.
I think we can talk a little bit more about what you're specifically interested in doing. There is the ability to, I guess, share this information that is not individually. So let's chat a little bit more.
Okay, thanks.
So you showed the Python API. Can you say a little bit more about the throughput? So a typical batch of 10,000 alerts every 40 seconds. Is it possible to process with one core, or do I have to be more clever than that? And when I say process, I mean just to send to DevNull, just to get a feel for how fast things are.
Yeah, that's a great question. The capability hasn't been fully tested, and I think the answer is dependent on the science case. So there are definitely instances where you can. Sure. You want to send it to where?
To nothing. DevNull/dev/num.
Okay, I'm not sure I understand your question.
He just wants to iterate over the records without doing any processing. So like print alert ID for each record. And he's wondering how many cores does that take?
Right, okay, thank you. So again, my answer is we haven't fully tested the extent to which this could work. Michael has his hands up.
Are you asking how long it takes us to run it when we're doing the Google Cloud, or are you saying if you want to stream to your laptop? Yes. Good. Mario's asking for the code showed on the slide currently, if he wanted to run that on where? On Google Cloud, what would you need? What are the resources you'd need to do that? Is that equivalent to the question of what resources we use to do that?
Let's suggest that these folks get together after the talk to resolve their questions. Thank you, Chris. Let's move to the next speaker. Sorry about that. I just know that I stand between you and dinner. So, all right, our next speaker is Guillermo talking about Alerce.
Oh, spoiler alert. All right. Hi, everyone. My name is Guillermo Cabrera Vives. I'm the PI of Alerce, and I'm here on behalf of the Alerce team to try to convince you in 7 minutes that Alerce is cool. So we all know how the alert brokering system works. So basically, alerts are going to be sent to the brokers. And in the case of Alerce, we provide with different user interfaces. One of them are web interfaces. We also provide you with Jupyter Notebooks. We have a Python client and Jupyter Notebooks with examples on how to use it. We provide you with APIs and direct access to our database, but also you can get access to the output stream, like the real output stream, to follow up on Tom's. So yeah, I have to be very straightforward on this. We still have no Rubin alert, okay? So we don't know how this is going to behave when we get Rubin alerts, but what I'm gonna show you, it's what we expect to have when Rubin alerts start flowing. And so one of the interfaces we have is what we call the Supernova Hunter. And this is basically a system, it's an interface, a website that shows you all the supernovas that appeared during the last night. Another one of these interfaces is what we call the Alerce Explorer. On this, on the Explorer, what you do is you can select one of our classifiers and select for a particular type of objects and then explore what those objects are, particularly focused on the light curve, but you also have the image stamps and you have cross matches with other catalogs and images from Pan-STARRS, in this case for CDF. We also have whoops. We also calculate the period. So if you're interested in periodic sources, what we do is we give you access to the full periodogram, and then what you can do is, whoops, sorry, I was on the period. Okay, I cannot play that video, but you could have seen the video of the periodogram, and you can choose the best period for your specific object. And we also implemented watch lists, so you can upload a list of sources, and then whenever something changes with that sources, you create specific filters, and then you get an alert, you get an email or an update on what has happened there with those particular type of sources. We have the Python client I told you about. So we have Jupyter notebooks with examples on how to use it, but it's as simple as doing a pip install Alerce. And then you import the Alerce client, you do client equals Alerce, and then you can do a query on objects. For example, this is an example of AGNs, and you say the class name is an AGN, and what probability you want, and a lot of filters. So more information on this can be found here. You can also query directly our database. So basically you create a connection to our database, and then you generate your own query, and you can query directly on the database. If you want to know more about the database, there's a link over there. And behind the scenes, what we do is we calculate around 185 features that are publicly available. You can get access to them through the database. And we also have a lot of machine learning models running behind it. This is, Alerce works with a broad taxonomy. So we have from microlensing events to supernova to blazars, Cepheids, pulsating periodics, eclipsing binaries, and a lot. A huge taxonomy. So if you're interested in any of these, you can get access to them through our interfaces. So one thing that we're very proud on is on our machine learning development workflow. So basically, we develop a lot of models, but we don't only develop the models, but we also make sure that those models make sense, make astrophysical sense. So basically, we start with the graduate students that develop those models. And once one of those models is particularly interesting, we find like it's promising, then it goes to our development team led by Ignacio Reyes, who's that guy over there. He doesn't look very happy, but he's usually very happy, except when models don't work. And he puts the models into production. And so after that, the models go into staging, and when they are in staging, it gets to our quality assurance team led by Alejandra Munoz, who's over back there in the audience. And what she does is that she does a lot of plotting and making sure that all the models work on the real alert stream. And so not only on simulations or specific data picked for those particular models. And if Alejandra is okay, then it goes into production, and then it goes back to our interfaces. Some examples of scientific discoveries that have been made with Alerce. Well, we have a community of users from 139 countries. We are the third reporter on supernova candidates to TNS. We are also the third reporter in terms of supernovas that have been spectroscopically confirmed. So we're very proud on this. We have around 20 accepted publications, and these over here are the publications that reference Alerce. This was, I think I made this last night. And a lot of people use Alerce, and it's basically because of what it says here. It's because of our rapid and complete database, informative websites, connections to external archives, and user-friendly Python API access. And that's not something we said, it's something that this author said on that particular paper. Some examples, I don't have time to go over all of these. I have only 15 seconds left. But these are examples of things using our classifiers. So from supernova, cataclysmic variables, AGNs, you can read them later. But basically, there is science being made by this, by using Alerce. And this is like a spoiler for my talk on Thursday on anomaly detection with Alerce. And it's basically saying that all the papers that have found weird things in CDF data has been done by discovering things that don't look the same on two different data sources. So we're going to talk about that on Thursday if you participate in that session. So that said, that's the end of my talk. If you're interested in Alerce, you can talk to me, you can talk to Alejandra, Marcio, Susana. There's a few of us here, and thank you.
Thank you. Great talk. I use Alerce every day. I love it. I have a question. Once you start getting LSST alerts, what will be when will you decide to promote something to TNS?
When?
Oh, yeah, when? What's your plan there? And do you think TNS is ready? That's a great question too.
So that
the transient name server, the actual official IAU, yeah.
Okay, so that's a very good question. It depends on how many supernovae we find per night. It depends on how many of those there are. So I have to be very clear. We use the Supernova Hunter to submit the alerts to TNS, right? And so that means that someone is looking at the Supernova Hunter every morning, okay? And that someone is usually Alejandra, who's over there. So say hi, Alejandra. We all love your work. So basically, so it's not only Alejandra, it's many of the Alerce team, but the thing is that they look at this and every morning they spend how long? Maybe an hour per morning, just making sure that what they submit is real. So yeah, so we're trying to make this as pure as possible. I mean, if you want to help, yeah, sure. We really need help with this. Yeah.
All right, we're making connections. To your question about is TNS ready? They have told me in the past that they think they're ready for the rates, and I know that they now have Rubin and Rubin filters and everything all loaded in their system, so that it is ready to record appropriate metadata for LSST when that happens. Other questions? All right, let's thank Guillermo again.
Thank you.
Our next speaker is Rachel Street. She's going to talk about Tom Toolkit and Aeon Plus.
Down. I'm a little smaller than everybody else. Hello, everybody, and thanks for this opportunity to speak. We've had some excellent talks so far from the folks who are producing this wonderful alert stream, and also from some of the brokers who are going to handle it for us and classify the events. So I'd like to take this opportunity to talk about some of the tools that are available for us as scientists to take that alert stream and turn it into hard science projects. Of all of the tools I'm going to present today, and there are many, obviously this is the work of many, many people, so let me acknowledge at least some of those people on the slide here before I begin. Okay, so first of all, I'm going to talk about the 4 segments of this slide. We've already heard about the 2 segments on the far left of the side. LSST will produce this huge, great flood of alerts. Also the prompt data products, they'll be propagated to the Rubin Science platform and also through the alert brokers, of which there are many. The role of the research teams is then to draw on both of these resources in order to pull down all of the information they are interested in for their topics of interest. And the tool available in that space is the TOM, or also known as a Marshall system, as you heard earlier. Much of the science is going to require some of the observing facilities, so I'll talk a little more about the tools available in that space. But most recently, there are also tools developed for sharing the results of our follow-up and our analysis in real time. So I'll talk lastly about that section of this diagram as well. So first up, the target and observation managers, also known as Marshall systems, and that's supposed to play automatically. There we go. The role of these systems is really to run the science program that is based on this huge flood of alerts and take some of the workload of really managing the day-to-day management of accumulating data on all targets from various different data sources. It provides a platform for data visualization tools. It also provides a platform for you to plug in your own data analysis code, which is critical for much of our science, is to be able to customize these tools. They're at their most powerful when they talk to other tools in the ecosystem, and this is particularly important if they can communicate programmatically with the Rubin Science platform, with alert brokers, and also with observing facilities. They also provide the opportunity for us to automate our analysis. So some of the follow-up programs have to be real-time, they have to be very dynamic, and so this automation is an essential tool. So for Rubin building a Tom or a Marshall system of your own, there are two main platforms available if you want to roll your own. There's the Tom Toolkit, which you've seen in the slides. There is also the Sky Portal. They're both open source projects, so you can go ahead and download the code, customize it to your heart's content. If you're involved in one of the Rubin Science collaborations, you may well find that your collaboration is already building such a system and customizing it for the science you want to do. In particular, I see Monica is to give us a talk in a moment about the GOATS system, so you'll hear all about that. TVS is building the OPM platform, and the screenshot here is the FOMO system, who win the awards for best name of Tom system out there. Well played. That's by the Solar System team. Moving on to the Aeon Plus system. This is in the observatory area. This is a collaboration between observatory operators in order to really optimize the workflow to enable time domain science and time domain follow-up. There are two key technical aspects to that. One is that we should be able to just request observations to be done in flexible modes of observation in queue mode scheduling or in target of observation opportunity. This network is recently expanded to welcome a number of new collaborators, including Keck, CFHT, the Skynet Robotic Telescope Network, and also we welcome the National Radio Astronomical Observatory. So we're looking forward to the future to making this truly multi-wavelength. We also work very closely with the Rubin in-kind facilities. If you're planning observations, especially of transient targets, it's very important to coordinate with other teams in that space to avoid us all rushing after the same target at the same time. This has proven particularly valuable, for example, in gravitational wave follow-up, where you have a huge localization region to cover and finite telescope resources. So the Treasure Map system was built and is available, intended to enable observers and surveys to share where in the sky they're going to be pointing so that teams are able to coordinate. Once again, I'll point out on the side here, this has a beautiful API, a user interface. I encourage you to check it out, but it also has an API, a programmatic interface. And so all of these tools are designed to work together as an ecosystem. Oops. No, carry on. The other side of coordinating observations is to know what telescopes and instrumentation are actually available. There's a new system called the HEROIC system being developed by the CIMA organization. The goal of this is to provide an online database of all the world's telescopes, including all the world's instrumentation, but crucially to also provide real-time information on their status. So this is really, really helpful if you're either planning a telescope proposal or you're running around looking to follow up something right this second now, this will be a really great tool. It also provides a generalized target visibility planning tool that works from multiple sites. And this will also operate not just the UI that you can see, but also a programmable interface should be available shortly. So once you've followed up your targets and you've done some wonderful science with the LSST alert stream, there are tools to allow you to share that discovery in real time. The General Coordinates Network is a long-established survey, very commonly used in the community. We've heard already about the Transient Name Server. They offer messaging and classification services and the ability to share information on your discovery in real time. There's also this new Hermes platform, which is also developed in collaboration with CIMA. The goal of this platform is to provide a more flexible interface that can not only do messaging, but also handle real-time data products, such as light curves or spectra, in a way that is more machine readable and more easily plugged into other services in the ecosystem. This also provides the opportunity to broadcast the message, not just to a single service, but across to other services as well. So you can relay information out to the GCN and TNS at the same time. Come on. Okay. So that was a pretty whistle-stop tour through a wide range of tools. So if you would like any further information on any of these tools, please feel free to come and find me. I'll be here at the conference all week, or reach out to any of the teams involved here. I'm sure they'd be very happy to answer your questions. There is one more slide that I would like to advertise, if I may. We have an Observatories Forum workshop that will be taking place in late September this year. The goal of this workshop is really to bring developers from the observatories themselves together with the science community, and it's especially the developers in the science community, so that we can make all of these tools and platforms really work for the science that you want to do. So that's going to be taking place in Santa Barbara in late fall. It's a beautiful time of year to visit, and I hope you can join me. Thank you very much.
Questions for Rachel? Sure.
Hi, Rachel. This is Shreya Anand. I was wondering if you could talk a bit about the difference between Aeon Plus and Aeon network as it was before.
Oh, thank you. Yes, with pleasure. So Aeon was the core collaboration between the original partners were led by Noir Lab, Gemini, SOAR, and the Las Cumbres Observatory. That was officially a formal partnership between those organizations. So what we wanted to do was to bring in many other observatories as we can, because it's best for science. But for practical reasons, some of our collaborators could not use the word partner because that had legal implications. So we've made it a collaboration. It's an equal collaboration, I assure you. That's it. That's the difference. The main one is that we're broadening out to new facilities that are pan wavelength.
Hey, Rachel, great talk.
Hiya.
Hi. On Aeon Plus, what is the timeline for maybe including DECCAM into Aeon?
Oh, that's great.
Just
Now,
to be selfish.
You may notice in the middle of this picture, I do in fact have the Blanco telescope. Noir Lab can speak to this most directly. They're in the process of bringing Blanco into Aeon. In terms of the software, that's a work going on that is focusing currently on the new firm instrument. They'll have to answer why that one was easier than the DECAM. Obviously, it would be fantastic for Rubin Follow-up to get DECAM into Aeon, and I would be very keen to make that happen. I think we should talk with Noir Lab folks about how we make that happen. But encouragement from the community would be very welcome.
All
right, let's thank Rachel. Our next speaker is virtual. It is Monica Sorensen. So I will stop the share. Monica, do you want to go ahead and share your screen?
Yeah. Can you guys see it?
Yep. Let me get rid of, okay. Great. Go ahead.
Okay, thank you. So hello, everyone. I hope you're having a great time in Tucson. So in this talk, I'll be highlighting two key time domain services of Nuala, namely the Antares Alert Broker and GOATS, which is a new target and observation manager for the community we are building here at Gemini. Okay, so as emphasized in previous talks, the community now depends on an ecosystem of software tools to handle the big data rates, data volume, localizations, and so forth. And the first tool here, directly interfacing with the surveys, is the Alert Broker. Antares, built by Nuala, is one such system. So it's, as mentioned in the previous talk, it's one of the 7 selected brokers, which will be receiving the full LSSD alert stream and will be processing and filtering them to find interesting events for follow-up studies. Antares has been built using industry standard technologies and is being deployed on the cloud. Users, however, don't need to know this complex internal system shown in the figure. Instead, one can interact with the platform via simpler interfaces like Slack, web browser, and so on. So currently, Antares has been processing public alerts from the ZTF survey, and this also includes adding value to the alerts by cross-matching with various legacy surveys. Antares also offers various other functionalities. So for instance, users can develop science filters using a dev kit that we have made available on the Nuala Astro Data Lab Science platform. And once the user is happy with the filter, they can submit it to Antares and run it in real time. One can also monitor interesting objects with direct notification sent on Slack of any alert hit. And then back to the time domain ecosystem, the next integral piece is the follow-up facility network, so in particular Aeon, which Rachel has already described. And Gemini is also part of this network, providing the largest aperture there. And finally, closing the loop is the data management service, so the archive, data reduction pipeline, science platforms, and so on. Now, all of these tools and services, they are no doubt essential, but they've also become a bottleneck to the science investigation process, because the user now needs to handle all of these tools, and that can in turn lead to a high entry barrier. So just to highlight how cumbersome the process can be, this is an example. So this is the current workflow at Gemini, and at each and every step here, users have to deal with a different service. So, evidently this has become a very tedious process. However, there's active development to modernize the software infrastructure at Gemini. So very soon, the proposal preparation and observation setup will be done by a new web-based application, which we are calling as Explore. So this will be part of the Gemini program platform, which Brian will discuss in the next talk. And to navigate the rest of the other steps, users will now have a new tool called GOATS, and that stands for Gemini Observation and Analysis of Target System. So it's basically a fully assembled target and observation manager that a user can run out of the box. And the goal here is to make Gemini follow-up more efficient and thus lower the entry barrier for the user community. In the next few slides, I'll show a few demo movies highlighting the capabilities of GOATS. So Antares has been closely integrated into our system, such that with the click of a button, users will be able to send the target information from the Antares website to the GOATS. So that's our landing page, and one will be able to launch the Antares website so directly from the GOATS interface. And then here on Antares, I'm selecting a transient. That's actually a very recent Type 1a supernova, 2025 RBS, I believe, that went off in a nearby galaxy. And then just clicking an icon, I can't see it, but it's right there. This target will be transferred to Goats, and you will see it listed right there. Okay, and that's the target detail page. All right, Goats will of course also allow triggering Gemini, but this is going to be done with our new observatory control system, which we're calling as the Gemini Program Platform, or GPP in short. So this is currently under development, but here in the movie, I'm pulling a test program that has been defined on the GPP Explore website, just to highlight how this interaction will appear on Goats. And that's the observation detail. We are also supporting lots of cool features on the Goats interface. So for instance, one will be able to see the status of Gemini. So you can get access to the weather URL to see if the observatory is accepting any TO, what instrument is available, and so on. And the Gemini Explore website that I mentioned is also directly linked there, so users can launch it from there. And here, I'm just giving a preview of the test program that I showed previously, how it appears on Explore. All right. Okay. One also doesn't need to leave the Goats interface to retrieve data from Gemini archive, so it can all be done automatically, as is shown in this movie. So for this supernova, I'm adding an observation ID. I think this is Dave's program. So the status of this is completed, and then just hitting that submit button, all the data of this observation ID will be downloaded on Goats, and that the nice thing here is that it happens asynchronously in the background, so users can do other tasks in the meantime. So for instance, launch Dragons, which is the data reduction software of Gemini. And we have also included a lot of nifty features to make Dragons production very user-friendly on our interface. So for instance, one will be able to see the actual data reduction code that is being used. You can edit it if needed, and access the documentation of Dragons on the fly, and so on. And finally, the NOAALab Astro Data Lab Science platform is also integrated into Goats. So users can transfer data from Goats to Data Lab just with the click of a button, as is shown here. Okay, and yeah, so just clicking that, the file is getting sent to Data Lab, and one can launch Data Lab from the Goats interface and avail various services offered by the science platform. So for instance, the Jupyter Hub environment, where you can analyze this transfer file. So that's available right there in the remote storage space. And finally, this is my last slide. I will be having the first beta release in early September, and we'll be welcoming the user community to test it out. So stay tuned for the announcement, and I'll be happy to take questions. Thank you.
Thanks for that great talk, Monica. First question is from Beth.
Hey there, Monica. You can't see, but you've got a full room here of people listening very carefully to that great progress you just presented. So, right, on Cerro Tololo and Cerro Pichon, you have all these NOIR facilities, Rubin itself, SOAR, CTIO, and Gemini South. And, you know, we've heard about how there's just going to be this absolutely breathtaking, crushing amount of alerts coming out. Rachel and others have given excellent context into the infrastructure being set up to help the community wrap their hands and brains around this incredible flow. And so, like, the question I have after hearing this set of great talks in this session, and Monica, maybe for you, and I think I saw Cesar Briseño online posting a comment about SOAR and CTIO, but I'm not on the Zoom chat, so I can't see it. My question is, like, as a user, you know, we're hearing things that sound really siloed about facilities that are all part of NOIR Lab, and like new great software being developed that's specific to different facilities, rather than what may be like, what work is being done to work towards an integrated, what may be a more efficient and effective integrated system for the user? Like, what advice do you have for what users can look forward to in the years to come, and how these facilities all in NOIR Lab can be working together at full steam?
but that's a fantastic question. I can feel the pain of the user community as well. Like, sometimes it's mind-boggling that you have all of these facilities operated from the same organization that appear to be siloed. So, as a solution to that, so Goats is right there. I did not emphasize it in my demo, but other facilities like SOAR, which is already Aon enabled, which means there is a Tom Toolkit API, so thanks to the Tom Toolkit team led by Rachel. So that is already part of Goats, such that users will be able to trigger SOAR as well. So not just Gemini, but I sort of like focus on Gemini here just because of the title. But in the future, besides like Gemini, SOAR, like all of our facilities, we're trying to make it as part of the Aon system. So Brian will also be speaking about that. And that the user interface, we're kind of like expecting that those will be that interface that will allow one to kind of trigger any facility and like see the statuses and whatnot.
Any more questions for Monica?
Hi, my name is Christopher. I would just take Beth's comment and elevate it to the level of Aura, because you might as well include Hubble and JWST. And to the extent that you think that the astronomical community has some influence over those broad decisions, I would just ask those who have Aura representatives start to take action so that those people, if this is your sentiment, articulate that point of view at the relevant meetings.
All right, let's move on to our next talk. Thank you, Monica. The next talk is again a remote talk by Brian Miller. Brian, do you want to see if you can share your screen?
Okay. How does that look?
All right, looks great here.
Okay, thanks. And sorry I can't be in the room with you today. And thank you very much to Eric for taking on the leadership for the session. So I'm going to jump right in, sort of following on what Monica just said. She sort of focused on and kind of left us here, where we have filtering interesting targets out of the brokers and organizing them in the TOM system so you can do prioritization. And then you need to coordinate with the facilities to get the data taken. So I'll be focusing on this side here in terms of how you can use NORLAB facilities to get those observations and data, and how we work within Aon a little more. So SOAR works within Aon via the Las Cumbres Observatory portal. You can put in observation requests via their web interface or with APIs. And on Aon nights on SOAR, then it sends the plans in real time to the observation schedule manager at SOAR, which coordinates figuring the instruments and taking the data, slowing the telescope. The data, if it's Goodman data, can be produced with a pipeline. And then the data goes to both the Las Cumbres Observatory portal and the NORLAB archive so you can get at it. This is a screenshot of example of the Goodman spectroscopic pipeline, which runs in a web browser. So there's no software installed, and it runs fast enough to do basic data reduction in real time. Of course, we're continually adding new instruments and telescopes and modes. So SOAR currently works with the Goodman Optical Imager Spectrograph and Triple Spec. NSF is now funding the addition of the iSpy near-infrared imager to Aon. That's implemented and awaiting testing when the instrument is available, and working on implementing conditions constraints as well. And I think this is going to be, of course, important topic. Blanco is next. Aon has been implemented with the new firm. It's a wide field near-infrared camera. It's complete, and the Aon nights start in September, and BCAM is next. So hopefully not too much longer. There's another project ongoing, which is implementing real-time difference imaging with DECAM and alert generation, also funded by additional NSF funding. Gemini, because of its Q mode, it's sort of Aon mode all the time, and you can use almost any of our instruments for targeted opportunities, but the main workhorse facilities, the optical instruments such as the GMOSs, and near-infrared images like GNIRDs and Flamingos 2 at the two sites are probably the most used, and they're on the telescope most of the time. 3 instruments are available at any one time, and switching between them takes less than a minute. Also, I'll point out or emphasize that a new instrument called Scorpio is coming soon. And this is being designed as a broad wavelength LSSC follow-up machine, give you simultaneous 8-band imaging or long slit spectroscopy from the G-band to the K-band in one shot. It's currently undergoing integration and testing, and we expect commissioning in 2027. So Gemini works now within AEON, meaning you can send observation requests via existing but rather limited API, but will better support AEON via this Gemini program platform that Monica mentioned, and a very set of Gemma projects. So Gemma, as mentioned, is the core of a brand new observing system, kind of built from the ground up to make things easier to use and take advantage of our 20 years of Q experience. Explore is here, replaces, which is a web browser-based application, replaces the desktop PIT and OT that you may have used. This application communicates with a single database in the cloud, which allows both north and south instruments, observations for those instruments in the same program, and adds a lot of automation in terms of creating sequences and calibrations, constraints that we needed for our scheduler, and makes the code a lot more modern and maintainable. So this will have a big impact on how you can submit TOOs and the capabilities, as Monica sort of alluded to, but I want to show kind of a demonstration of how it could work. So start off with Explore. This is an empty program, no observations there. I'm going to jump into my Tom, which is not as nice as Goats, but it'll hopefully do the job. I'm going to select a ZTF object that I've downloaded from Antares. I checked that it's visible from Gemini South, so I'm going to try to trigger on it. I pick my program that I have access to. I pick the observing constraints, which are now physical conditions on targets, they're not bands. And then I put in science requirements like the wavelength, signal noise I want there, the minimum resolving power, and it will give me a list of all of the instruments and modes that meet those science requirements that I have access to. They're on the telescope or they're approved in my program. So I can pick one of those configurations. I hit submit. There's the entry in the Tom database. If I jump over to Explore, there's the new observation set to ready with all the target information, the guide star selected automatically. There's the conditions, constraints, and the instrument detailed configurations. It's run the integration time calculator on that. And using that, it's created a sequence that will meet those signal to noise. And that is ready to observe. That'll be picked up by the scheduler in the next run. So about the scheduler, we're implementing this real-time scheduling and data reduction as part of the NSF-funded Gemma project. Been running for a few years. The scheduler is under construction. It will update observing plans for in real time, meaning less than a minute as changes occur. And it will schedule north and south together as sort of a mini network. The real-time data reduction is based on this Dragon's Python pipeline environment. It initially supports all facility imaging and long slit, GMOS long slit. We're using it at night for quality assessment, and real-time quick look reduction is in early testing. And the archive has been updated to handle process data. And I have to mention, of course, that Goat is now a really good platform for reducing your data as well with Dragons. So I've been mentioning GPP for many years, but it's actually becoming very real now. We've started the early science and use phase, which we call XT, part of our end-to-end testing. We have taken the first nighttime data with GPP, and here's a reduced Dragon spectrum from one of those nights. And we've been in the process of converting some 25A long slit observations into GPP, and we're trying to get those observed now. But the next phase is called XT1, which we're actually happy to announce a call for proposals for early science with GPP and GMOS long slit. It's involved about 20 hours per telescope, which gives us an evaluation of the whole system, initial testing of the scheduler, and to get feedback from users. That call should open up next Monday, August 4, with a deadline of August 22. You should get sort of official announcements end of this week or early next week. So stay tuned for that. Unfortunately, that won't include the TOO capabilities, but we're starting to incorporate that, and that will be tested during our XT2 phase, which as we roll out new instruments and modes, we will convert existing Q observations to use GPP, work with the PIs, and get data on some various fixed GPP nights. And I think we'll be probably reaching out to various TOO programs to help test the system when we have TOOs ready to go. And we expect GPP to be in operations sometime next year. So we're entering the home stretch on that. There's another observing opportunity that's coming up. This is sort of a DD project for rare sources, following on various MMA time domain meetings that we've had recently. We're starting to organize a working group to plan a program that would follow up on sort of very uncommon sources, sort of the unknown unknowns in time domain, using about 20 hours per semester of DD time over about 3 years. This is just getting going. See Yi's talk in the morning TVS session, and please sign up if you're interested in participating. So in summary, NORLab has and continues to develop the sort of end-to-end set of capabilities for time domain. We keep adding new instruments, modes, telescopes, and we'd like to engage with all the community to ensure that these systems are built to purpose and that we can give you really good science. So thank you very much.
Questions for Brian? All right, I'll ask one. Brian, what's kind of the pacing item for Scorpio's availability? I know it's been in development for a little while.
Yeah, just as all new instruments, you run into problems as you go along and you have to solve them and just keep going to the next one. So right now they are integrating the hardware and testing all the software. It's just a matter of going through all the steps.
All right, thanks so much. Our last is Steve on the in-kind.
Thank you. Just to give a quick update on contributed telescope facilities through the Rubin in-kind program. I'll make it quick, show you where you can find this information so you can go have drinks and dinner, et cetera. Just a quick overview. There are a number of facilities that are going to be offered through the Rubin in-kind program. Most of these facilities will be offered to our communities through the NORLab time allocation process. So the same way that you would apply for telescope time on Gemini or any of the MSO observatories, you'll be using to apply for time on these. There's a website that you can go to, part of the in-kind program, that lists all the different facilities, information about them, how long they expect to be available. That is your primary resources of things. The first facilities were offered for the semester of 25A. We had a beginning. We have more coming in this next call for proposals, very coming shortly, and then a few beyond there. Right now, we're offering this time as single semester allocations. As we get started, these are a lot of times a 10-year availability on some of these programs, and we look at how the oversubscription rates and how the science is evolving with Rubin, whether we want to include these into long-term status availability and even into survey programs. So we're going to be looking into that. What's available now? So there is some time available at the Nordic Optical Telescope, about 70 hours per semester. Strictly for supernova classification. So this is a very kind of an oddball. Programs are allowed to use this. They classify them and then the results are made public onto WISE-REP TNS, usually within 24 to 48 hours. This has been running pretty well. And we had our first in-kind facility paper submitted based on time on that telescope. The Milankovic telescope in Serbia is available. It's about 2 nights per month on a 1.4 meter imaging telescope. It has AON capabilities. This is a little undersubscribed right now. So if you're looking for optical follow-up of sources, do you want to apply for this? Those will be available in 2026A as we are expecting the following resources. So one of the most exciting, we have 5 nights a year. So we'll announce in the call for proposals exactly how much for that first semester. But 5 nights a year for using the Prime Focus Spectrograph HSC. So this is the dark/gray time, very, very highly in demand. We'll be some of the first people to be able to use PFS. That'll come up. For this group, I think the 150 hours per semester on the KMT network telescope. So it's 150 hours on each, one in Chile, one in South Africa, one in Australia. These will be pre-allocated nights that can be run as AON nights, but there's also some TEO availability in the first 30 minutes and the last 30 minutes of each night. So we can run triggers daily on those. So look for more information coming on that. We also expect 25 hours a semester on SALT to become available starting in the 2026A thing. This will be Q scheduled. The next ones that are really going to be coming online after this are there's going to be GTC time. This will have an alternate proposal route, not through the NORLab Time Allocation Committee. We'll be advertising more of that. Time on VLT and the LBT via an Italian in-kind contribution. Expect to be ready. That may be sooner, but probably after this semester, the 26B. And then a number of additional 1 to 2 meter telescope facilities in New Zealand, South Africa, Turkey. These will be really great longitudinally placed so that, and hopefully get them involved in the AON network so that you'll be able to cover almost at any given time, have a facility that is able to observe your targets. So we're managing these. More is coming. It's very exciting. If you have questions, you can talk to me. You can post those questions on community. You can send them to the in-kind help desk. I also want to point on Friday, there's another session on collaboration for complementary external data sets. So how can we work together as a community to put in big science proposals rather than just individually using all these resources. And that's it. Thanks.
Thanks to Steve for getting us back on time. Any questions?
Thanks, Steve. That was really helpful. As a non-expert, I'd love for you to highlight what's sort of like the science sweet spot for the overlap between where Rubin as a 6.7 meter aperture telescope and the 1 to 2 meter aperture follow-up resources. Like, what's the scientific sweet spot? What's the magnitude sweet spot?
So there actually is a fair amount of overlap that works pretty well. I think you start worrying about a little bit on the saturation limits on the high end. These facilities are available, a lot of it's being thought of as a Rubin follow-up, but they're not just available for Rubin follow-up. So the entire US community will be able to do that. But I think that a lot of things where there are going to be discoveries in Rubin, but you're going to want a lot more cadence or something like that. Extreme follow-up for maybe a few days or something that you follow at a different cadence over the semester. And that's where these facilities are really going to, I think, bring in some added value to that.
Hey, Steve, thanks for the update. For facilities like PFS in particular, it's critical to have some kind of survey call, especially for large programs that need, calibrations for photo Zs or things of that nature.
Yeah.
So could you be a little bit more specific about when the survey calls might start?
So I will say that there's separate contributions from Subaru that are specifically PFS-oriented surveys for photo Zs and things like that. And those are considered contributed data sets working directly with Desk and things like that to develop these targets and things like that to do those. I don't have it for when the general availability of the 5 nights a year of the sort of open access time, when we would consider making that part of the survey availability is still TBD. So.
And I guess if I can make a quick suggestion, given that this is early days, it might be worth by resource actually having some track of which proposals made use of which resource and what the scientific output from that particular proposal was, because the in-kind contributions in many of the cases end fairly quickly, and you can imagine a process to extend them, but it'd be really valuable to have some information about how productive were they to see if we could, renew them, extend them, get more resources in the future.
Definitely on my mind of how to keep track of all that, so we can really say this is where it was really valuable. Here's where it is. Thank you.
All right, let's thank all our speakers. Tony has asked for the last word, so let's go ahead and clap, but then Tony has asked for the last.
Yeah, just a brief comment. We've heard these beautiful plans for follow-up. And my worry, I've been worried about this for some time. My worry is following up what? So we've heard earlier on wonderful, very focused plans for brokers to pursue certain known knowns, highly tuned to detect those known knowns. But I think in the interest of furthering, maximizing the science potential from Rubin, we have to worry about the detection of the unexpected. And so, you know, there are probably ways of conquering this issue, but if we finally tune the brokers to detect the known physics in the universe, we're going to miss the unknown physics.
All right, on that inspiring note, let us adjourn to dinner. Thank you all again for being part of the session today, and thanks again to all the speakers.